Okay, we have here the Picket N600 slide rule. This is a 6-inch pocket slide rule. I had shown you this before on my introduction video. There's the model number right there. What I want to do is go ahead and take a look at the Mantissa scale. So we're going to go ahead and flip this over. And here's the other side of the slide rule. The Mantissa scale is denoted by this L right over here. And if you take a moment to look at the scale, you'll notice that it's the only scale on the slide rule where you have evenly spaced digits. Alright, it goes, here's 0.1, 0.2, 0.3, 0.4, 0.5. It's just like looking at any other ruler. And how do we use it? Well, what we do if we want to take the log base 10 of a number, we go ahead, since the L scale is on the slide, we'll use the C scale instead of the D scale. Go ahead and let's say we want to take the log base 10 of 2. We'll line the cursor up with 2 here, and the log base 10 of 2 we find is pretty close to 0.3. And if I go ahead and evaluate that over here, here we have 0.301. Let's try with a different number. Say, let's take the log base 10 of pi. Alright. Okay, if I take the log base 10 of pi, I should get something slightly less than 0.5, say 0.496. Let's go ahead and replace this with pi. 0.497. Pretty accurate for a little tiny pocket calculator. Okay, well, I had mentioned before that if we weren't taking the log base 10 of pi, but rather something like 314, instead of getting 0.497, what we would get is 2.497, right? If it's 314, that's a magnitude of 2 places. So we have 314. And there you have it. So that's how you use a Mantissa scale for values that are greater than 1. Alright, if you gotta go less than 1, you kind of end up on the other side of this thing. And how do we deal with that? Well, you remember the trick I showed you with using a reciprocal. I have to go ahead and show you a new scale here, the CL scale. The CL scale is exactly the same as the C scale, and its endpoints are 1 and 1, just like the C scale, except that it's in reverse order. Right, the primary numbers on the CL scale go 1, here's 2, 3, and they always put this in red. Right, here's 4, 5, 6, 7, 8, 9, and 10. And a funny thing happens when you reverse the scale like that and put it up against the original scale. You're able to get reciprocals off of it. So you notice where the 2 is. It's right over the 5 on the other scale. Well, 1/2 can be represented quite easily as 0.5. Right? 1/2 is equal to 0.5. Or 1/5 is equal to 0.2. Right here we have 3, and sure enough, if you look up at the CL scale, well, here's 3, then you go your secondary numbers, and you go out 3 places there, and tertiary, you go another 3 places, 3.333, or 0.333. Right, and it works all the way down. So if I wanted to find out what 1/8 is, alright, I would find it's 0.125. And that's what the CL scale does. It's a way of getting reciprocals very quickly. Well, I don't have to calculate what the reciprocal is. All I need to do is look at the CL scale, and instead of taking my value off the C scale, take it off the CL scale. Alright, let's say I wanted the log base 10 of 0.487. Well, there's 4 up here on the CL scale. 4, that's 5, 6, 7. 0.487 would put me right about there. Maybe a little further. Okay. So for the log base 10 of 0.487, I should get as a negative value, negative 0.313, it looks like, right there. Let's go ahead and put that into Maple. 4 point, I lost my mouse here. 0.487. I'll get negative 0.312, which is exactly what I had here. Okay.